Hey guys, welcome back to AlgoYogi, and we are doing tree series right now. So let's move on to our next problem in the list, which is construct quad tree. Let's visit the problem on LeetCode and let's summarize what the problem is asking us to do. Problem is asking us to do. Okay, so construct quad tree. What's a quad tree? In our quad tree, we're going to represent our node in this format. So let's read the problem. Given a n into n matrix grid that has zeros and ones, we want to represent this grid as quad tree. This is quad tree for this particular grid, and they have explained here. It's simply saying that 0 is false and 1 is true. And a quad tree is a data structure in which each internal node has exactly 4 children. Besides, each node has 2 attributes. And 2 attributes, what are those attributes? These are value and isLeaf. These are 2 attributes that we are talking about. So each node is going to have these 2 attributes, these 2 attributes, and 4 children. Just like in normal tree we have a value and then left and right child, it has these 2 attributes, value and isLeaf for checking if the node is a leaf, and 4 children. That is it. It's just we have to convert our grid that has zeros and ones into this quad tree. How are we gonna do it? It has explained later in the problem that we need to divide it in a way that we basically keep breaking it down until the square matrix has all same values. So like here, if you see this matrix of 2 by 2, we broke it down into basically 4 nodes, and those all 4 nodes are here. Parent is here, the value is 0, value is 1, and isLeaf is 0 because it's not a leaf, right? Here they are a leaf. All these values are leaf, so that's why isLeaf is true, and value is depending on whatever value they have here. So this is top left, top right, bottom left, bottom right. So let's see this on a bigger example, which is this one. Now this will basically explain us what exactly the problem is asking us. So let's try to understand it. Now, for any matrix, parent is not going to be the leaf unless it's like an empty matrix they are giving us. Then it will be a leaf and value will be 0 or 1, whatever. I would say 0. We can provide 0. Then see here, we're going to check if this entire matrix contains all the same values. If it does, then we could just simply return one node is leaf, which is 1, and value as whatever this matrix had as value. Okay, so now this time it doesn't. So what we're going to do, if this has a length of n by n, we're going to break it down into 4 parts. Okay, what are those 4 parts? These are those 4 parts: top left, top right, bottom left, bottom right. And we can simply just break the matrix into 4 parts by just dividing our n into n by 2 and n by 2, and basically just accordingly calculating the dimensions of this matrix. Now, are we done with it? No. So once we assign these 4 parts over here that we just divided, then again we're going to ask if that divided part contains, because we have to reach the leaf nodes, we have to process all the leaf node. So since this one, this one, this one, and this one, those 3 parts contain all same values, then that means we have arrived at the leaf node while basically dividing our whole matrix until we reach a leaf node, you know, when we are converting it to a quad tree. I don't think it's that hard to understand. I guess you guys already understood it by now, that what this problem is actually asking us. So then this particular part, top right, is not done yet. Why? Because we see all the values of this matrix are not really same. Then what we're gonna do? We're gonna divide it into even further 4 parts. So these will be those 4 parts, and here we can say this top left is right here, top right is here, and bottom left and bottom right. Okay, now you can see these all values are same. That's why we have reached the leaf node. So approach to solve it is going to be very simple. When you will look in the code is really simple. It's just we have to see, you know, understand the logic that we will be following. It's taking that grid, we're taking this entire grid, and we're checking if it contains all same values. That's going to happen in n square time complexity. So the time complexity that will implement the solution will be big of n square. And same for the space complexity, because every time no, actually no, not for the space complexity. Space complexity will be big of h, which is the height of the tree, but that will depend on how many times we're gonna break this down until we reach the leaf node. Okay, so we can just simply call that space as big of h. Now, so we take the matrix, we take this entire matrix, we check if all the values are same. If they're not, we divide it into 4 parts and then check the first value, and it's not a leaf. Then we create the root node and then assign 4 child to it, and the leaf is going to be basically 0 or false, and then value is going to be the value that is in the first place in that matrix, which could be represented by row and columns. So let's go to our code editor and implement the solution, and it will be, you will see like how simple it is when we write down the code. So let's write our solution here. We're going to create a helper function. Let's call it DFS. It's going to take 3 arguments, basically size of the matrix, that is n, and the first starting row and column of the matrix that we are currently processing. Let's have a variable called maybe let's call it is leaf, and is leaf is going to be true initially, but then we're gonna iterate over the grid and check if all the values are same. Then we'll keep is leaf true if there was somewhere like a mismatch where all the values were not same, then we'll mark it false, and based on that we will return the basically the leaf node. We just return back as a, we'll have that as a base condition. Otherwise we will break the matrix into 4 different quadrants and then return the root assigning all those 4 quadrants as its children, and this entire tree be like the node as being the parent node. Okay, so let's have a, let me, for I in range that is n, for j in range is also n, and now let's check if my grid at value at the first value, basically R and C, is not equal to this, and basically R plus I and C plus I. So you guys might be asking why I'm doing R plus I and C plus I. The reason is because it's not just this grid that I am comparing the value, because later I will be breaking this down into multiple grids and I will be sending those values and R and C. So it has to take that R value, the starting point, which could be in, let's say if it's a big matrix, you're breaking it down into 4 different quadrants, then for one matrix R and C could be at 0 and 0. For some other matrix, if it could be 0 and 5, if let's say the size of the big matrix was 10 into 10. So it could be like these could be different values. Now if this was the case, then we we will mark isLeaf as false. Okay, and if we're marking it false, then we can just break out of here, and once we are out, then we can check if isLeaf, and if it is still holds true, then we can return the node with value, we can call it 0, and true, because it's a leaf node. That's what it said. So value would be, we have been assigning 0 like to all the leaf nodes, and the parent node doesn't matter, and just return leaf node as true. Otherwise we're gonna break it down. Let me focus on the code here so it's clear to you guys. Now otherwise we're gonna break it into 4 different parts, and those 4 parts would be, let me, top left, and that would be basically calling DFS on sending the size n, R and C, because that's the top left quadrants, and then we will have top right would be this, but C will be basically moved n times further, and bottom left would be, we will increase row by n now, and this time n is not like original n but like half of our original grid. And then finally we have bottom right, that this time we will basically increase R and C both by n. Okay, and now finally we can just return our root node. Let's call it node, value is 0, and it's not a leaf node, so we're gonna say false here. And then finally we can just send all these values over here. These are all its children. Sorry, I'm being just lazy here. Should have typed them. I guess typing would take less time, but anyway, I'm tired and lazy. Okay, this is it. And then finally we can just return DFS on our main grid, which is length of the grid is our n, and then RNC would be 0. And here we have also covered the part where size of the grid is, let's say, just 1. Then here it will check that values, all of the values were same. Then it will just return this leaf node as the base case. So let's try to run it. Let me zoom out. We had a small mistake. That is, when we are at the leaf node, we are returning the leaf node. Instead of 0, we basically return the value that the leaf node is supposed to have. I misread. I thought because when it's not a leaf node, you could return anything, and when it's a leaf node, you could return anything. However, that's not the case. When it's a leaf node, you return this. And there was a mistype over here. And let's try to run it now. Trying to zoom out. Okay, awesome. And cool. All right, let's write down the time complexity. Time complexity for it would be big of n square log n. Why? So this is where the n square is coming from. We are checking for each grid. We are checking going to each element. That will, worst case will happen, you know, for the all the one main grid, which is like n into n. And here we are basically breaking it down, you know, until the leaf node. And worst case that can happen is big of log n. That is basically, you know, like doing it log n times, because that number of time we will be breaking it, right? And for space complexity, it will also be we're not storing anything. However, we are putting this on the stack, so that will be log n, you know, breaking it, or log n could be called h, but we don't know what h will be, and we are assuming in best case scenario h will be log n. That is the height of the tree. Okay, so this is it. And let's go back to AlgoYogi and mark our problem solved, and see you guys in the next problem. Please keep making, we have done a lot of problems, and you guys can make use of AlgoYogi. And please like the video, subscribe. That will help, that will keep me going. Thank you guys. Let's see you all in the next problem.